Kia ora Year 13 and Year 12. Here's the first part from question 2 of last year's differentiation exam. So our first question asks us to differentiate this expression here. This is a straightforward application of the chain rule. So my inside function is x squared minus 4x. I'm going to need to differentiate that. And my outside function is 2 times something to the power of 5. Okay, so let's get started. It's going to go like this. dy by dx will equal 2 times 5, so 10, x squared minus 4x to the power of 4 times 2x minus 4. Just one thing that I've noticed a lot over the last few years with mistakes made by students in the straightforward questions, and that's that you must remember to put your brackets around that term because it's all of this times this. So don't write this. That is not the same thing as what I've written above. Okay, so please be careful with brackets. All right, after that little lecture, on to question B. We've got a percentage of seeds germinating, and it depends on how much water they're getting in the seed bed. And we've got a model for that function, right? So a real life question, P is the percentage of seeds that germinate, and W is how much water is applied. And we can put on between 0 and 15 litres of water. And if you want to, you can grab your graphics calculator and graph that function to see what it looks like. We've got to find the amount of water that should be applied daily. So what we need to say is for a maximum, we need the gradient to be 0. So the gradient is going to be P dash W equal to 0. So step 1 is to find that derivative. So P dash of W will be 96 divided by what, W plus 1.25. That's the derivative of the log function. Don't need to worry about the derivative of W plus 1.25 because it's just 1. So we're doing the chain rule without really thinking about it. Minus 16, and that equals 0. So solving that gives me the following. 96 over W plus 1.25 is equal to 16. 96 is equal to 16 times W plus 1.25. 96, blah, blah. I'll just do it without talking. So we're nearly there. We've got 76 is equal to 16W, which leaves me with W is equal to 4.75, right? Dividing 76 by 16. Now, we should really check that it's a maximum. It doesn't mention doing that in the schedule, but I'm going to do it here because it's pretty easy. So P dash of W is equal to 96. Oh, why am I doing it in there? That's just way too squashed. Pop it up in here. Hopefully it won't go wrong. So P dash of W is equal to 96 times W plus 1.25 to the negative 1 minus 16. So the second derivative here, we want to be able to show that it's negative for a maximum. And that's very straightforward because it's just negative 96 times this. If you look at how that comes out, it's negative 96 over some number squared, which is negative, and that's what we want for a maximum. Okay, so that's that question done with just a little bit extra. So in this case, you didn't need to show that it was a maximum. But in harder questions, you might need to show that. So just remember your second derivative test. For a maximum, we want the second derivative at a point to be 0. Sorry, not to be 0. The second derivative to be negative for a maximum. Right, on to the harder part of this video, which is question C. Right, so in C, we've got a curve. The curve is y equals the square root of x. And we've got a tangent to that curve drawn at the point 4, 2. And we need to find the coordinates of point Q over here where the tangent intersects the x-axis. So what are we going to do? Well, we're going to find the equation, find the tangent equation, and then solve for y equals 0. Remember, where something intersects the x-axis is where the height is equal to 0. Okay, so I'm going to do that on the next slide, I think. Yep, I am. Just going to change the pen colour because red is annoying me. Right, what have we got? Well, where did that come from? Oh, don't know what's happening. There's some strange things happening when I touch things on the screen. So y is equal to x to the power of a half. dy by dx is 1/2 x to the negative half, which is 1 over 2 root x. Now let's think about the equation of the tangent to the curve. Well, we're going to use this. Y minus y1 is equal to m times x minus x1. And we're doing it at the points 4, 2. So the 4 and the 2 are giving me those numbers. So m is going to equal 1 over 2 root 4, which is 1/4. So we're good to go now. We've got y minus 2 is equal to 1/4 times x minus 4. So y equals 1/4 x minus 1 plus 2, which is 1/4 x plus 1. Right, now the last thing we've got to do is to figure out where is the intercept. So we're now solving for 0. So 0, let's just put a wee wiggly line down there. 0 is equal to 1/4 x plus 1. Negative 1 is equal to 1/4 x. X is equal to negative 4. Now let's just read the question carefully to see what we're asked for. Well, we're not just asked for the x coordinate, we're asked for the coordinates of point Q. So it's a very easy last step, but we should remember to do it. And that is that Q will equal negative 4 for x and 0 for y. Okay, so that's that question done. It's a nice wee question where you've got to differentiate, find the equation of a tangent, and then solve for a particular place on that line.